So today we're going to be solving linear inequalities. Now, we did simple inequalities at the beginning of the year, and when we graph them, remember, if it were this symbol, oops, let me fix this. When it was this symbol right here, or the other way, remember, it was an open circle. But when it had the underline to it, it was the solid circle, and then you had to show which way would make it a true statement. So like, for example, on number 2, if I put any of the numbers right here into this, it gives me a true statement. So when it's an inequality, it's not just one set answer. Now, in this lesson, we're actually going to be graphing not simple ones, but things that look like an equation. So just like on yesterday's test, you needed to put it in slope-intercept form to decide how many solutions. We're going to be doing the same thing here. Our first step is going to be rearranging our equation into y equals mx plus b form. So for example, on this one, negative 3x plus 2y equals negative 4. Add the 6. And then I get 2y. 4 and 6 aren't like terms, so I just write them side by side. And then now I'm going to divide everything by 2, all 3 pieces. And now I have an equation in y equals mx plus b form. When I go to graph this, where does my first point go?
-2.
Good. So my first starting point is here, which I put right here. And then from there, my slope is the 3. I can make it into a rise and a run. So from this -2, I'm going to 1, 2, 3 up, and to the right 1. Connect the dots, make your line. This is going to be step 1, or step 1 is going to be rearranging it. Step 2 is going to be graphing it. And then step 3 is going to be shading it. And we're going to learn how to shade in a minute. But before we get into the shading, we are going to first see what a linear inequality is. And basically it's similar to an equation, but the only difference is we're going to replace the equal sign with one of these symbols. So instead of y equals 3x plus 5, just a random equation here, it'll be one of these symbols and then the rest. So a solution is going to be any ordered pair that makes the inequality true. And we're going to do the checks like we did before. So here we go. Remember, we did this on the quiz and the test, where I gave you an ordered pair, and you had to replace it for x and y and see if you got a true statement. If you got a true statement, the answer was yes. If you got a false statement, the answer was no. So if I take my -2 and my +4 and put it in for x and y, I'm going to put 4, here's my inequality. So I'm basically replacing the y, let me highlight instead of right on top, y with 4, and then the x with the -2. So 4, is it less than 2 times -2 plus 1? What's 2 times -2?
4.
And what's -4 plus 1? Is -3, or is 4 less than -3? No, it's not. So then you would say no, and see here they put not a solution. We're not shading yet. All we're doing is testing it. We haven't gotten to the shading yet. Let's try another one.
Wait, was that shading?
So this was just, only difference is it's an inequality. So here's another one, 3, 1. Y is greater than x minus 4. Remember, the 3 is x, the 1 is y. So 1 greater than 3 minus 4. What's 3 minus 4? Is 1 greater than -1?
Yeah.
Yes, it is. So you will say 3 comma 1 is a solution. So this is the same thing we did before when they were equations. Now they're just inequalities. It's like what we did before. They have 2 more examples when they did it. Notice this one, when they put it in. Let's just do this one just to demonstrate. So 4 comma 5. When I put in the 4 and the 5, what's 4 plus 1?
5.
Is 5 less than 5?
No.
No. If it had the or equal to, it would have been a true statement. But because 5 isn't less than 5, then it's not a solution. Okay? So the beginning part is really basic. All right. Now we're going to get into the graphing and the shading. So 2 things you need to know. So remember when our inequalities were these? It was open circle, remember? Now, when we go to graph our boundary line, when it's these symbols up here, it's going to be a dashed or a broken line. So see how they've made dot, dot, dots here? But when it's got the or equal to with it, then it's going to be a solid line. So we're going to be making our boundary line based on our equation. And then from there, we have to decide, are we going to color the top part of the line or the bottom part of the line? Okay, and we're going to see an example of this in a minute. Right now, just realize that this symbol and this symbol is a broken line. This symbol or this one is a solid line. Get into the shading now. So these are the 3 steps. Step 1, put it in y equals mx plus b. Step 2, graph the line. Step 3, we're going to shade. We're going to learn how to shade. All right, so here's our first example. We have y less than or equal to 2x minus 3. Is it in slope-intercept form? Is y by itself? Yes, it is. All right, next what we're going to do is we're going to take out the inequality symbol. You can just leave it on my desk. And then we're going to make it an equal sign so we can graph a boundary line. Everybody with me so far?
Yeah.
Okay, so now I'm going to graph this line. Now, this symbol and this symbol, what kind of line am I going to create when I connect my dots? A solid line. So I'm going to go ahead and graph this equation. What's my starting point?
-3.
Okay, so on -3, on the y-axis, I put a dot. From there, what is my slope?
2.
It's 2 over 1. So from this -3, I'm going to rise 2 and run 1. And we said it's a solid line. Connect your dots. And now, general rule of thumb, if it's greater than or equal to, we're shading the top. If it's less than or equal to, we shade the bottom. Now, some people get confused, but a fail-safe way to do this is to plug in an order pair. The easiest order pair to check is the order pair 0, 0, because it's got less work to do. So I'm going to take my original inequality. I'm going to plug in 0, 0 for x and y and see if I get a true statement. So 0 for y, 0 for x, 2 times 0 is 0, and then -3. Is this a true statement? Is 0 less than or equal to -3? No. So because it's not true, I can't shade the side that had the 0, 0. I'm going to color the bottom. And like I said before, when it's less than or equal to, it's going to be the bottom part of the graph that you're going to shade. Is that making sense? Pick an order pair. Now, let's say you saw that it was less than, and you're like, okay, I don't want to pick a side that's not going to work. I want to pick an order pair that I know is going to work. So I could have picked any point that's below my line. So let's say I picked an order pair that's sitting over here. Let's say I picked 5, 0. When I plug it in, it needs to work. If it doesn't work, then I know I shade the other side. So if I plug that in, I plug 0 for Y, 5 for X, 10. Is 7 greater than or equal to 0? Yes, it is. So the point I picked, it is in the blue colored side, so it's good. So this is how you do this. You can check it. Let's try another one. This is still the same thing. Here they're substituting in the 0, 0 to do the check. They're telling you 0, 0 is a good one to pick as long as it's not on your line. If it's on the line, don't pick it. It involves the least amount of work. That's why they tell you to pick 0, 0. All right, let's try this one. What's step number 1? Good. Solve the inequality for y. So I need to move the 5x. 2y greater than negative 5x minus 8. Now what? Still need y by itself.
Divide by 2.
Good. And I'm going to divide all 3. Good. So this becomes y is greater than negative 5 over 2x minus 8. Now, because I'm graphing this, I'm not going to make that 5 over 2 a decimal. That negative 5 over 2 is now my rise and run. Everybody with me on that? Okay, so now I can either go down 5 into the right 2, or I could go up 5 but to the left 2. I need to make a negative slope. Where's my starting point? Good. So negative 4 on the y-axis, and then from there,
You go 5 down.
I could go 5 down, and then 2 to the right, and then put a dot right here. Now, what kind of line am I making? Solid or dashed? Dashed, good. Dot, 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 dot. And then am I going to shade on top or the bottom when it's greater than? Okay, when it's greater than, it'll be the top. So I'm going to shade up here. Now, again, let's pick an order pair to double check that we picked the correct side to shade. So I'm going to use 0, 0, because notice it's in my red area here. So 0, is it greater than negative 5 over 2 minus 4? This becomes a 0. So is 0 greater than negative 4? Yes, it is. So because I picked 0, 0 and it was in the shaded area, I was looking to get a true statement, and it was. So I graphed it correctly. Good so far? All right. Here is their official nice and pretty graph. Again, notice their line was dashed, and then they shaded the top half because it was greater than. Here they plugged in 0, 0. They got the same true statement that I did, and so they know that they shaded it correctly. Fastest way to get y by itself would be to just add it to the other side. I could subtract the 4x, subtract the 2, but that's going to involve a lot more steps. So I'm going to add y to both sides. It's gone from here. Everybody with me on that? Okay, now, remember, I could turn this little symbol into either like an alligator, add some teeth, or make him like a Pac-Man, okay? Notice he's wanting to eat the y. So if I want to rearrange it, make sure Mr. Alligator here still eats the y. Everybody with me on that? That you could flip it around? Okay, now it's in y equals mx plus b form. I need to graph this thing. Where does my first point go?
Positive 2.
Good. From that positive 2, how do I move?
Up 4. Over 1.
Good. So from the positive 2, I'm going up 4 and to the right 1. Is it going to be a solid or a broken line?
Solid.
Solid line. Connect your dots. Make the boundary line. Now it's greater than or equal to. So am I going to shade top or bottom? Top. So I'm going to shade the top. One way to confirm if you colored the correct side is to plug in an order pair. Now let's say we didn't want to do 0, 0. Let's say I wanted to pick something that was actually in the red area. So I could pick maybe an order pair over here. Maybe we'll say it's order pair -3, 3. I could still do the 0, 0, but I should be getting a false statement. Now, I can either plug it into the one I rearranged or go back to the beginning. It doesn't really matter. So if I do it into the one I rearranged, is 3 greater than 4 times -3 plus 2? And it is, because 3 is greater than -10. So because it's true, I colored in the right side. Good so far? That's all there is to this lesson. Rearrange it into slope-intercept form. Graph the line, and then shade the correct side. You can double check your shading by plugging in an order pair. Here is their graph. Notice there's a solid line, and again, they shaded that top half. And again, they plugged in the same order pair, -3, 3, and they got it to satisfy it. Here's another example. Again, step number 1, rearrange. Here's their slope-intercept form. They started on -4. Their slope was a fraction, so they went 4 up and to the right 3 and put their dot. Notice it was this symbol, so it's a broken line. Which side do you think is going to be colored in, top or bottom? Bottom, good. And probably what they did on the next slide. There it is. Now, one other thing to remember is, remember whenever you multiply or divide by a negative number, your inequality symbol reverses. You guys remember that? Okay, look what they did here. They decided to take it the long way on this one. And let me do it the long way. I'll work it all out again. So instead of just adding the y like we did before, they went ahead and they moved the 2x. And you can do this. Then they moved the 4. Then this is a -y, so we have to divide everything by -1. And whenever you divide by a negative with inequalities, this symbol reverses. You guys got to remember this from way back when. And now we have the equation that we can graph. Start at -4, rise 2, run 1. Good? Right? And here is their graph. They start at -4. It was this symbol, so it was a broken line, and they showed it below. And they plugged in an order pair. Here's just another example. It's already solved for y. Their graph has a solid line. It's greater than, so it's above the line. Here is a word problem. You're going to need to know those words, remember way back when, from at least and at most. So at most is going to be less than or equal to. So she only has 285 beads. She wants to make necklaces and bracelets. Every necklace uses 40 beads. Every bracelet uses 15 beads. So we're going to create an equation, an inequality, that'll represent this. They're telling us the letter X will be necklaces and Y will be bracelets. So here, they've come up with the equation, because 40 beads for the necklace, 15 for the bracelet. And we can't use more than 285 beads. You'll go ahead and rearrange it, get your slope-intercept form, and then grab the boundary line, and then any combination of beads in here will make bracelets and necklaces without going over the 285 beads that she has. So what it means is, let's say she wants to make 2 necklaces and 4 bracelets. So that would be like this point right here. So you go 2 bracelets, or let me erase, I'm off a little bit. So two necklaces and 4 bracelets would be this order pair. Or she could make a combination of 4 necklaces and go across and 6 bracelets. Anything in the red area would be an appropriate number of combinations. Is that making sense? So here they've done several. They got 2 and 8, so 2 necklaces and 8 bracelets. Or 5 necklaces, 3 bracelets. So just turn them into pairs and just remember that necklaces were the X's and Y were the bracelets. Here's another word problem. Again, you're going to write your linear inequality and then graph it and then come up with combinations. We're going to do a couple word problems in the homework. I'm going to work through the first one with you. And here is their example for green olives and black olives. And here is their graph solution. And again, you're going to shade it. So any combination in that green area would satisfy this inequality. Here's just an example. Here is if they already give you the graph and you have to come up with the inequality. First thing you should do is you could set up your Y, your X, and what we're going to fill in is the symbol, and the y-intercept, and the slope. So maybe I need to make 2 blank lines here. So you could already start out by putting your y and x in there. First thing I'm going to look for is my y-intercept. What is it?
1.
Okay, positive 1. So that's what I'm going to put on that line. So on this line will be y-intercept. Is it shaded above or below the line?
What?
Is it on top or on the bottom? It's on the top. It's greater than. Is it a solid or is it a dashed line? Is this line broken? Or
Wait, it's, sorry,
it's the dashed. So because it's above and it's broken, it's only going to be greater than. Now I have to figure out the slope. So I'm going to count my rise and my run to figure out the slope. I look for points that are in the corners. So see how this one's right here? The next one that I can see that's in a corner looks like it's about right here. So I'm going to count my rise and run. So I'm going to go 1, 2, 3, and then 1, 2, 3, 4. Now, notice if I'm going to go down 3 and to the left, a negative and a negative movement makes it positive. Or one other thing is just look at the direction of the line. See how it's going up? So I know I need a positive slope here. So the number I fill in here for the slope is 3/4. It'll become easier. This would be a good skill that you should practice, because sometimes on the SAT and the ACT, they're going to say, find the equation of the graphed picture. So look for key things. Look for the direction of the line. Is it a positive slope or a negative slope? And also look for the y-intercept. Those would be key things to look for first. When we're dealing with inequalities, we're also going to look to see if the line is solid or broken. Here's another example. Again, look for the y-intercept. Look to see if it's shaded on the bottom or the top. It's on the bottom. It's a solid line. So from there we can fill in what we need. So because my y-intercept is -5, that's what goes here. And then from there I can see that it's a solid line and it's below. So I'm filling in the less than or equal to. And then I'm also going to count my rise and run. So notice I'm going to go up 1 and to the right 2. And I would get 1/2, and it's a negative slope because I went left. So that's why it's -1/2. And then here's another one, and you're going to write the inequality. We've got a couple more examples. Okay, your homework over the long weekend is both practice A and practice B. I'm going to work on practice A with you right now, and we'll get a lot of it done. So let's go ahead and open up your homework.